Good morning, everybody. Welcome to our last meeting of Chem 1105 with your host, me, Dr. White. Now, a couple important things. At the end of today's lecture, I'm going to end a little earlier. I'm going to give advice how to do a good interview. It works. It works for me. It's worked. I've gotten feedback from my students, and I'll be cutting that out of the video. Again, at the end, I'll be doing advice on how to interview well. Next, let me remind you, Monday at about 9:55 a.m., Monday morning, I will send out an email with the password for your version of the final exam for this class. Excuse me. And normally, if we're face-to-face, the way I write the 11:05 final, most students are done within an hour. You'll have 2.5 hours, no, actually 2 hours to take the final and have it uploaded by noon Monday as a single PDF file. And if you don't do it as a single PDF file, I reserve the right to take off 25 points. I don't have time to play with people who don't follow instructions. All right. Next, this morning I sent out, and let me show you. Thumbs up, people, for one of the last times. You say, calculate points needed on the final exam. Thank you, everybody. All right. Now, I sent this out as an email. It's an announcement. And this is points needed to calculate the final needed calculate points needed on the final exam to get a certain grade. Now, there are two methods. Method one assumes you've handed in all the labs, and most of you, not all of you have. And X is equal to the total test points, which you can find on Blackboard in the grade section or grade book section, plus your extra credit. To get an A, it's 360 minus X. Approximate amount, and B 320, C 280, D 240 minus X. Now, let me warn you, if you're someone who only needs, and there are a couple of you, like 60 points out of 110 on the final exam, you'll say, oh, I don't have to study hard. And I've seen this more than once, twice, or 3 times, or a student who's doing good says, oh, I don't have to study hard, and they do awful on the final. I mean, awful. And they get a grade lower and sometimes 2 grades lower than what they should have done if they just bothered to study like they did for the hourly exam, study for the final. So remember, study for the final like you need every point, even if you don't. Now, there's a method too, because a number of you have not handed in a lot of labs. And this method is total test points, test point total, extra credit, and your lab total. All the lab points. You can find your individual labs on Blackboard, what I graded them so far. And for an A, it's 477 minus Z, B 424 minus Z, C and D, and so on. And that might help you and give you some, I don't know, motivation to study hard for the final. And also for some of you know, you're in a good position. All right, now, what's the best way to study for the final? Use your hourly exams as practice problems. Don't just look at them, cover the answer and try them, or get to similar problems in the practice problems where you can see the answers. But that's the best way. Now, next Monday, you'll take the final, and I guarantee by, say, 4 p.m. Friday, I will have all your final exam score, your lab total, and everything else, plus your grade in Blackboard. I'll enter it into the COD system when I finish, about the time I enter, right before I enter it into Blackboard. And sometimes that takes up to 24 hours for you to see it officially in, what do they call it? My COD access or COD access, or however you see your grades. But the one in Blackboard will be the same I put into the system. I will send out an email and post an announcement when the grades are available. I say Friday, 4 p.m. I hope to have it done a lot sooner. So every once in a while, check your email. And the only thing I will tell you is, which I do face to face also, I will not send back an email with your individual point total on the final exam. However, if you're within 10 points of a cutoff, I go back and regrade the final exam totally to make sure I didn't make a mistake. All right, now, what I'd like to do for a while today is go through a couple more important problems that you should know how to do. Hint, I had to sneak that in one more time, maybe more, one more today. All right, let's look at the whiteboard. Everybody see my whiteboard? Thumbs up, people. Thank you, Ruben. All right, let's look at the first one. How many molecules are in 8.713 moles of H2SO4 sulfuric acid? So what are you trying to find? How many molecules of sulfuric acid? What are you given? These many moles of sulfuric acid. Now, this is all we have to start with. So I'm going to start with it. Profound. And if there was a ratio to convert it, I'm going to have you have some fun too on our last day together. What units go here? What units go here? What units go there? Your turn. And while you're doing that, I'm going to open up something real quick because I forgot to do that. All right. What do we put right here? What we're trying to get to. And now we use, and I can use it again, we use our good buddy, our good friend, unit analysis. And how do we use unit analysis? Whatever we're trying to get to goes on top of this ratio. The units, whatever we're trying to get rid of, go underneath. And now I'll write that in. And where do I get a relationship between moles of sulfuric acid and molecules of sulfuric acid? Well, guess what? You don't have to memorize that. Why? because it's an important information final exam. 1 mole of a compound, and sulfuric acid is a compound, equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. Again, 1 mole of a compound equals Avogadro's number of that compound. And now I can put in here 1 mole of a compound equals Avogadro's number. And notice moles of sulfuric acid cancel out because anything divided by itself is the number 1. And now I pick up my calculator, turn it on, clear it, and take 8.713 times 6.02 double E 23. And my calculator gives me this number. Give myself which if you put it down, I'll take off a point because on to the final exam, it will say, please use please use significant figures for all calculations. And I'll let you round that off to the proper amount, and then I'll do it. Go. And the answer is, this is 4 significant figures, 3 significant figures, exact number. Exact number doesn't play a role in the calculation to determine significant figures. And therefore, how do you do this? You say when you multiply and divide, the number you get has the fewest significant figures is how many significant figures your answer should have. So it should be 3. 1, 2, 3. Keep the first 3, use 5 to round off, set 5 or higher, and the answer is 5. So I'll drop all this, increase this by 1. And that's what you get. Next, next question is, how many moles of water is 2.67 times 10 to the square grams of water? So what are we trying to find? Moles of water. What are we given? And how do we proceed? Well, this is the only number we have to start with, so we will, or I will, and I hope you do too. If there's some ratio, what units do I want to get to? And what units go on top and bottom of the ratio? Your turn. All right. What are we trying to get to? Moles of water. And now it's time to use your good buddy, your good friend, unit analysis. I love that whistle. And in this, after this class, if you have whistle withdrawal symptoms, come back and look at my video or videos. Whatever we're trying to get to goes on top of that ratio. Units, whatever we're trying to get rid of goes underneath. And where do I find a relationship between moles of a compound and grams of a compound? Well, let's look at important information, final exam. And you can see 1 mole of a compound equals the molecular weight of the compound in grams. And the molecular weight of that compound is the sum of all atomic weights in that compound. So for every 1 mole, I have to calculate the molecular weight of water. And we've done this before, but let's do it one last time. Water has 2 hydrogens, 1 oxygen, each hydrogen, the atomic weight, and that's the number underneath the symbol for hydrogen. The 3 significant figures is 1.01. There's 1 oxygen, the atomic weight of oxygen to 3 significant figures, 16.0. Do the math. Add these together. You get the same number of significant figures to the right of the decimal as the number that has the fewest significant figures. This has 2, this has 1, which is the lower number. Hopefully all picked 1. So here's my decimal. I'm going to keep this. This is the number I round off. It's 4 or less. I'll drop it. So the number here is 18.0. And before I pick up my calculator, notice grams of water divided by grams of water equals 1 is canceled out because anything divided by itself equals the number 1. And now I'll pick up my calculator, clear it, 2.67 EE2 divided by 18.0. Oh, wow. And my calculator throws me this number. And I'll let you figure out how many significant figures in the right answer for that number. And the answer is, this is 3 significant figures, exact number. And that's 3 significant figures. So how do you round this off to 3 significant figures? Keep the 1, keep the 8, keep the 4, keep the 8. Use the 3 to round off. It's 4 or less. I drop that. And the correct answer is 1.48 times 10 to the first. And that's how you do it. Now let's continue on. Does everybody see problem number 5 on your screen? Thank you, Ruben. All right. For the following reaction, H2 plus hydrogen gas, H2 plus chlorine gas makes 2 HCl. How many grams of chlorine are needed to make 125.6 grams of HCl? Now, what are we asked to find? How many grams of chlorine, Cl2? We're given 125.6 grams HCl. And here, there's no way you can go from grams of one compound to grams of another. You need 3 steps. Mass calculations for reactions. Step 1, whatever you're given the grams of, you convert to moles. Step 2, you convert moles of what you now have to moles of what your answer, the molecule of your answer. And step 3, you convert moles of your answer now to grams of the answer. And let's look how you do that. First step, we want to go from grams, in this case A is HCl, to moles of HCl. We have the grams, we want to go to moles, use unit analysis, Moles go on top of the ratio, grams underneath. Remember, 1 mole of a compound equals its molecular weight in grams. Over here, I have the molecular weight of HCl, which is 36.5. Do the math, 3 significant figures is the answer. And this is one of those multi-step. You can round off at the end or each step. I'll calculate both ways. Now, step 2, we want to go from moles of HCl now to moles of chlorine. And here we have our moles of HCl. We want to go to moles of chlorine. Again, use unit analysis, which I hope this semester has been your good buddy, has been your good friend. Whatever we're trying to get to goes on top of the ratio. Whatever goes we want to get rid of goes underneath. Where do I get these numbers? From the balanced chemical equation. The coefficient, the number in front, tells you molar relationship. When there's no number, it's the number 1. And therefore, what this really tells us is 1 mole of hydrogen gas, H2, reacts with 2 moles of, I'm getting ahead of myself. Let's try that again. Instant replay. Let me back up the tape. And remember, when there's no coefficient, it's the number 1. And this tells us 1 mole of hydrogen gas, H2, reacts with 1 mole of chlorine gas to make 2 moles of HCl, hydrochloric acid. So for every 1 mole of chlorine, that's where the 1 came from, I make 2 moles of HCl. That's where the 2 comes in. These are exact numbers. And this is the number we get. We now have moles of chlorine. Are we done? No. We want to get to grams of chlorine. And step 3, we now have moles of chlorine, moles of B. We want to go to grams of B, in this case, chlorine, Cl2, gas. I have the moles. I want to get the grams. Whatever I'm trying to get to using unit analysis goes on top of this ratio to convert it. Whatever I'm trying to get rid of goes underneath. Where do you get these numbers? 1 mole of a compound equals molecular weight of that compound in grams. Over here on the right, no, the left, I have 2 chlorines, each the atomic weight to 3 significant figures for chlorine is 35.5. And you multiply it, you get that number, 71.033. And notice here, this is one of those cases where if you round off at the end or round off each step, it's the same. Can you keep a secret? Since you guys are here, which I appreciate it, and not everybody's going to watch the whole video, I buried this now in the middle of the video. There's a reason I'm going through these practice problems. Hint. All right, now let's continue on. When we talk about gases, important gas law is the ideal gas law. And if we look at number 11, everybody see number 11? Thumbs up, people. Thank you, everybody. A tire contains 25.67 grams of nitrogen gas, N2, 26 degrees C, 705 torr. What is the volume of the nitrogen gas in the tire? Well, first of all, is anything changing? No. And you're dealing with a gas. Immediately that tells you ideal gas law, PV equal nRT. What are we trying to find? The volume, V. What are we given? A weight of nitrogen gas. We're given a pressure. Remember, torr is pressure. So is millimeters of mercury. And we're given a temperature, degrees C, degrees Celsius. I almost said the old name, centigrade. Degrees Celsius is temperature. Now, in case you forgot, there's an important information, final exam, the ideal gas law, PV equal nRT. Remember, pressure, and this is a common mistake students make in this problem, pressure has to be in atmospheres, volume will always be in liters, but N is the number of moles, but you'll be given grams, and temperature has to be in Kelvin, but you'll always be given that in degrees C, and the universal gas law constant R right here is 0.821 atmospheres liters per mole K. 0.0821 is a calculated number and it has three, the version we use in this class, three significant figures. So if I look at this, I say, well, I got to get volume. How do I get volume? Solve for volume. I have to get rid of the pressure, P. So when two things are divided, multiplied by each other, and you want to get rid of one of them, you divide by it, because anything divided by itself is number one. Whatever you do to one side, you have to do to the other. And I did. And volume equals nRT divided by P. Now, first of all, N has to be moles, but we're given a weight. So we have to go from grams of nitrogen to moles. We've done this before today. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Where do you get this numbers? 1 mole of compound equals the molecular weight, and the molecular weight is the sum of all atomic weights. In this case, 2 nitrogens, each nitrogen weighing, having atomic weight to 3 significant figures, 14.0, 28.0, and this is your moles of nitrogen. Next, you need pressure. Pressure has to be in atmospheres. We have 705 torr. We want to get the atmospheres. Again, use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. Where do I get some ratio of atmospheres or relationship atmosphere to torr? Well, in case you forgot, important information, final exam, 760 torr equals 760 millimeters of mercury equals 1 atmosphere. So when I go back to my problem, 1 atmosphere, 760 torr. These are both exact numbers because they're part of, actually, that's a defined ratio, a relationship, really. And therefore, 3 significant figures. My answer is 3 significant figures. Finally, degrees, temperature in Kelvin, you're given 26 degrees C. And in case you forgot, important information, final exam, Kelvin equals degrees C plus 273. So it's 20 degrees C plus 273. That degree C is 26. Therefore, temperature in Kelvin is 299. Put the numbers in, and we calculated for this. R, which was an important information, final exam is here, temperature here, here's the atmospheres, and we get 24.3 liters both ways. I didn't even realize I had key problems for the final exam. I'd forgotten about that. I highly recommend you go and look at this. And let's look at one. And some of these I've already done. Let's look at Number 14, how many grams of sodium chloride are needed to make 341 milliliters of a 9.77 capital M NaCl solution? What are we given? Grams of sodium chloride. What are we trying to find? Sorry about that. Grams of sodium chloride. We're given 341 milliliters, and we're given 9.77 capital M NaCl. Capital M means molarity, moles per 1,000 milliliters. So that means 9.77 moles of sodium chloride per 1,000 milliliters. Now, there's no way anyone can go from directly milliliters to grams. You can't. You need 2 steps. And in case you forgot what those 2 steps are, let's go to important information, final exam, the molarity 2-step problems. Step 1, milliliters to moles. Step 2, moles to grams. So now we know what to do. Let's do it. So in step 1, we want to go to milliliters of sodium chloride to moles of sodium chloride. So I have 341 milliliters. We got that from our problem. We figured it out over here. I want to go to moles of sodium chloride. We're using unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And now, where do I get these numbers? Right here, by knowing 9.77 capital M NaCl is the molarity, 9.77 moles of sodium chloride per 1,000 milliliters. So I put the numbers in there. 1,000 is an exact number, 3 significant figures with the number 3. Boy, does this seem like I said 3 a couple times? Anyways, but that's not what we want. We want grams of sodium chloride. So step 2, moles of sodium chloride to grams of sodium chloride. Here are moles. We want to get the grams. Again, use unit analysis. Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. Where do I get this relationship? From the fact that 1 mole of a compound equals its molecular weight. The molecular weight of sodium chloride is the sum of the atomic weights in the molecule. 1 sodium, 1 chlorine is 58.5, and therefore do the math. And in this case, whether you round off at each step or at the end, you get the same answer. Now, let's look at number 16. What is the pH of a solution with the hydronium ion concentration 1.0 times 10 to the minus 3? What are we being asked to find? The hydronium ion concentration. What are we given? We're given the hydronium ion concentration equals this, and the pH is minus the log of the hydronium ion concentration. Put that in. When it's 1.0 times 10 to the minus x, the concentration of the hydronium ion concentration, the pH is x, this case 3. I won't go through it again, but you should know how does a towel work, and you should know how does soap work. Go back and look at the video, or check if you were writing it down for test number 4. Those are things you should know. You should also know the pH scale. And the pH scale goes from 0 to 14, never lower than 0, never more than 14. When you're at pH 7, it's neutral. Hydronium ion concentration equals hydroxide. When you're below 7, acidic, hydronium ion greater than the hydroxide. And when you're greater than 7, your basic hydroxide concentration greater than the hydronium. When you add an acid to water, the pH goes down because it becomes acidic. When you add a base to water at pH 7, the pH increases because you're making it basic. And the first day of our lecture of this class, I said, my world of chemistry, mine, is your world of chemistry. You just don't know about it. Now you do. You know a lot more about chemistry than most people in the United States or the world. Think about that. Next time you're outside and you feel the wind in your face, those are molecules of nitrogen, oxygen gas. You know those are atoms held together by chemical bonds. Next time you put salt on your French fries or whatever, you know that's a molecule that has ionic bonds. And with that, I'm going to say goodbye. And then after I say goodbye, I'm going to be doing my tips for how to do a good review. So with that, I'm going to do an early goodbye, but stick around if you want to listen to those tips. And for the last time this semester, gang gesund, go in health. Bye.